Your table looks fine. It has a primary key. Each column has a data type. And each cell has a single value. But something still feels off. Some columns only depend on a part of the primary key. This issue will lead to all kinds of insert anomaly, update anomaly, and delete anomaly. How do you fix such a design? You need help from something known as the second normal form. In this video, I'll walk you through a simplified and a full version of the second normal form, and explore how to use the second normal form to guide the process of normalizing database design. By the end, you'll have a good understanding of the second normal form and how to use it for normalization. Maybe we'll start with a simplified version of the second normal form first. A few words on normal forms first, in case if you need to refresh your memory. So what are normal forms? Normal forms are the rules that can guide you break down a messy big table into smaller, more manageable tables. There are multiple normal forms, including the first normal form, second normal form, and the third normal form, and it can go on. Each normal form addresses specific types of problems. The normal forms build on each other with increasingly strict requirements. They form a nested containment relationship. To achieve any normal form, you must firstly satisfy all the lower levels. For example, for a table to satisfy the requirement of the second normal form, it has to satisfy all the requirements of the first normal form in the first place. The first normal form checks the fundamental stuff, such as whether a table has a primary key or multi-valued columns, and whether each column has a data type. If you need to learn more about the first normal form, you can find the link of a video dedicated to the first normal form in the description. In this video, we will focus on what problems the second normal form aims to address. Remember, we're on our journey to understand a simplified version of the second normal form for now. If a table is in the second normal form, then every non-key column should depend on the whole primary key, not just a part of it. There are two terms that require some clarification. First, by non-key column, I mean the columns that are not the primary key or a part of the primary key, in case the primary key is a composite key that has more than one columns. Second, depends on here refers to functional dependency. To fully understand it, we need to introduce you the concept of functional dependency. What's functional dependency? It's about one piece of data determining another. For example, suppose you have a function called power that takes an input and returns its square value. Given any value of x, the output of power x is completely determined by x. You can also say that the result of applying the power function to a number functionally depends on that number. When the same concept is applied to columns in the same table, you will have something like this. If you know the value of column A, you can figure out the value of column B every time with no exceptions. For example, think about a table representing employees, and the table has only two columns, employee ID and employee name. Employee ID is the primary key of this table. Given a value of the employee ID, you can always figure out the corresponding employee name. We can say that employee ID functionally determines the employee name in this table, and express this dependency relationship using an arrow that goes from employee ID to employee name. You may also see the same relationship expressed as employee name functionally depends on employee ID. Okay? That's everything about functional dependency, and we are going to use it to deepen our understanding of the second normal form. And let's go back to the second normal form now. Beyond asking the table to be in the first normal form, the simplified version only has one criteria, which is about non-key columns functionally depending on the primary key. And it's worth emphasizing that it has to be the whole primary key, not a part of it. Let's focus on this criteria and explore what a violation of this criteria may look like and how to fix it. For example, think about an enrollment table representing which course a student enrolls in a database supporting a course management system. The enrollment table uses a composite key as its primary key, and it is composed of two columns, student ID and course ID. Beyond the primary key, the enrollment table has three more columns, student name, course name, and grade. When the table is populated with data, it may look like this. On the first look, the design of this table is fine, until you find out that the table contains three functional dependencies, and two of them only uses a part of the primary key. The first functional dependency is where student ID functionally determines student name. As you can imagine, the course ID doesn't help with that at all. The second functional dependency is where the course ID functionally determines the course name. Similarly, student ID won't help much with determining a course name. We typically refer to these two functional dependencies as partial dependency, because the determinant in the two relationships is simply a part of the primary key. Only the last functional dependency uses the primary key as a determinant. The primary key, student ID plus course ID, in combination determines the grade. How do you fix a violation of the second normal form like this? In general, you need to move any columns that depend on only a part of the primary key to a new table, along with the part of the key. The part of the key will become the new table's primary key. So in this case, you need to move student name plus student ID to a new table. And we can call this new table student, and its primary key is student ID. The same thing can be said for the course name plus course ID. We can call this new table course, and its primary key is course ID. What would happen to the old enrollment table? In general, you will leave behind only the columns that truly depend on the entire original composite primary key. For the columns that meet both conditions, they will be kept in both the newly created table and the old table, such as the student ID column and the course ID column. That's how you fix a violation of the second normal form. Now you have a good understanding of the simplified version of the second normal form. It's time for us to learn about the full version, or say the real thing. In the simplified version, we laser focused on the relationship between a non-key column and a part of the primary key. But the full version is actually a bit broader. Beyond the primary key, it also cares about any candidate keys in the same table. The full version of the second normal form states that no non-key columns depend on a proper subset of any candidate key. In other words, in a table that doesn't violate the full version of the second normal form, you shouldn't be able to find any non-key column that partially depends on the primary key or any other candidate keys. To make sure that we're on the same page, I want to explain what it means by a proper subset. It means a smaller group that's completely contained within a large group, and it can never be as large as a large group. Let's look at an example when this concept is being applied to keys. Think about the enrollment table in the database of a course management system. It's using a composite key as its primary key, so three columns in combination, including student ID, course code, and term code. They make the primary key. Okay? A proper subset of this key can be composed of any columns from the three columns, but the total number of the columns of this set has to be smaller than 3. For example, the combination of course code and term code makes a proper subset of the primary key, or student ID and term code. Whatever you do, in order to make a proper subset, it can't be the same as the original primary key. Okay? So By a proper subset of any candidate keys, the full version of the second normal form is still talking about partial dependency, but in a more accurate way. Now you know the definition of the full version of the second normal form. Let's compare the simplified version to the full version, so that you can have a robust understanding of the second normal form and appreciate the fine-grained difference between the two versions. Let's look at this employee project table, which represents the project's employees are engaged with in a company. The table uses a composite key as its primary key, which is composed of two columns, employee ID and project ID. Beyond that, it has three more columns, employee social security number, or short for employee SSN, project name, and credit score. In addition to the primary key, the table has another candidate key, the combination of employee SSN and project ID. The table has two functional dependencies. The first one is about the primary key functionally determining three columns, including employee SSN, project name, and project budget. The second functional dependency is about employee SSN, functionally determining the column of credit score. In case if you think the design of this table is ridiculous, it is indeed. However, a reasonable and authentic design that can differentiate the simplified and the full version of the second normal form doesn't really exist. So bear with me on this. Okay, let's continue. Does this table violate the criteria of the simplified version of the second normal form? Then you need to ask yourself, do you have a partial dependency on the primary key? Nope. So it's perfectly valid in the eyes of the simplified version of the second normal form. However, does the table violate the criteria of the full version of the second normal form? Employee SSN is a part of a candidate key, yet it functionally determines another column, which is the credit score. That said, you do have a violation, and the table is not in the second normal form. Okay? How do you fix the issue? In the same way as you would fix a violation of the simplified version of the second normal form. You will move the columns that depend on only a part of a candidate key to a new table, and keep only those columns that fully depend on a key in the original table. In this case, you will move employee SSN and credit score to a new table, and employee SSN, the determinant, will become the new primary key in this table. Beyond that, you will also keep the columns in the original table, the columns that are not partially dependent on any candidate keys. In our case, there's one column, employee SSN, that meets the requirement of both conditions, so it's gonna be kept in both tables. Okay? In real world, most violation of the second normal form is on the simplified version. The violation that happens to a candidate key that doesn't serve as a primary key is very rare, but being able to understand their fine-grained difference is still important theoretically. If you get it now, you can pat yourself on the shoulder. Good job. In this video, we covered a simplified and a full version of the second normal form and how to use them to guide your normalization of database design. I would love to hear what's working for you and what needs to change. This video is based on the book Grokking Relational Database Design, which dives deeper into database design using real-world examples to explain the concepts. You can find the link to the book in the first comment.